Okay, so this is the last one. And so for the last, for the last one we actually had this, and we found that c to the 1024 equals negative c. And you did a nice explanation of that. And now it's just changing this term to instead be 6.9. And the question here says, basically show that the terms of this to the 1024th power go to 0.
Alright.
Are you still in? Yeah, okay. Sorry, I thought I bumped the camera when the phone rang.
So we're gonna get, we have 5 minus lambda, this minus 4 minus lambda. This time it's plus 3 times 6.9, which is 20.7 since it's 0.3,
Yeah.
less than 21.
1.7. Yeah.
So we have minus 20, minus 5 lambda, so minus lambda, and then plus lambda squared, plus 20.7 equals 0. So lambda squared minus lambda plus 0.7 equals 0. Quadratic formula is probably the best way to go here again.
Okay.
So we get all the lambdas are going to equal 1 plus or minus root 1 minus 4 times this, 2.8 over 2.
Okay,
So,
that should right.
yeah.
Fair enough.
So we get 1/2 plus minus. I guess I is the square root of 1.8 over 2.
Okay.
So again, these are going to go 1/2 plus I root 1.8. More space in there. Let's write it over here. So 1/2 plus I root 1.8 over 2. 1/2 minus I root 1.8 over 2. Those are zeros. So I'm not sure if this is the best way to think about it, but we can kind of do the same thing we did it last time, and then we go over 1/2 and then up or down 1.8 or root 1.8.
Okay.
So since we know this has to be square root of 3 for this length to be 1.
Yeah.
We know these lengths are less than 1. So we're able to say that when we multiply over and over again, these lengths are going to get smaller and smaller.
That's a good observation.
So these are going to get smaller and smaller and eventually go to 0.
Okay. So the same thing's going to happen when you multiply these, start taking powers. They're going to continually rotate by 60 degrees, like yours did last time, going to -1 every third try and then rotating. But what's happening here is these ones rotate because, as you point out, their length is less than 1. As they rotate, what's going to happen?
They get smaller.
They get smaller. So they're going to
Spiral.
They're going to kind of spiral in, and they're going to get really small. And let's see. So the square root of 1.8 over 2 is about 0.67. So this is 0.5 plus approximately 0.67i. So
Plus or minus, but yeah.
Yeah. So I'll just find one of them. So we square this, and we get, oh yeah, of course, 0.45 plus 0.25. So plus 0.25. Take the square root of that. So 0.83 or 0.84. So that when we start raising and going to various different powers, in fact, can we take this to the 1024th power?
That would be too big.
Well, there you go. 4.9 times 10 to the minus 80.
So essentially 0.
Yeah, getting very small. Getting very small. Yeah, cool. That one tiny little change there. Previously, it was the lengths of these complex vectors was exactly equal to 1, so they just spiraled around in a circle. This time, for this matrix, as you raise it to powers, it spirals in. pretty cool.
Yep.
And again, you would never know that difference just by looking at it. Or I shouldn't say you'd never know. But it's not obvious that you would see that difference just by glancing at these matrices. So cool. Good job, man. Very good work tonight.